In this video, we're going to discuss partial differentiation and how to find partial derivatives. We'll see how partial differentiation helps us understand how a multivariable function changes with respect to just one variable while holding others as a constant. In calculus, when we have a function with multiple variables like f of x comma y is equals to x squared y plus 3xy squared, we often want to understand how the function changes with respect to just one of those variables, while keeping the other variable as a constant. This is where partial differentiation comes in. Partial differentiation is the process of finding a partial derivative. A partial derivative is essentially the rate of change of a function with respect to one specific variable. For example, if we want to see how f of x comma y changes as x changes while holding the y constant, we take the partial derivative of f with respect to x. Here's how it works. When we take the partial derivative with respect to x, we treat y as if it's just a constant number. So in this case, we look only at the parts of the function that involve x and differentiate them. Similarly, if we take the partial derivative with respect to y, we treat x as a constant and differentiate only the parts of the function involving y. Symbols used for partial derivatives using the functional notations. Z is equals to f x comma y. The following are the symbols that are being used. Partial derivative of z with respect to x or partial derivative of f with respect to x. The partial derivative of the function with respect to the independent variable x. Partial derivative of z with respect to y or partial derivative of f with respect to y. The partial derivative of the function with respect to the independent variable y. Let's try this problem number 1. Find the partial derivatives of u equals x cubed plus 3x squared y minus y cubed. When it said, find the partial derivative of u and has two independent variables, which is the x and the y, then what we ask to find is the partial derivative of u with respect to x and the partial derivative of u with respect to y. First, we solve the partial derivative of u with respect to x. In this case, we will treat the x, which is the x, as an independent variable and y is the constant. So we'll make this u is equals to x cubed plus 3x squared y minus y cubed. So this would be the independent variable, and these two would be the constant. Then we will solve this. Partial derivative of u with respect to x equals, what is the derivative of x cubed? So the derivative of x cubed would be 3x squared, because we are differentiating the partial derivative of u with respect to x. After that, plus the derivative of 3x squared y. As you can see, we have a two constant here, which is the 3 and the y. So we can just put together the y side to the 3 because they are both constant. So we can also multiply this 3 times 2 would become 6, then the constant y x minus, as I've said earlier, y is a constant. So this would become the derivative of y cubed would be a 0. So the final answer would be partial derivative of u with respect to x is equals to 3x squared plus 6yx. This is our final answer. The derivative of the partial derivative of u with respect to x. Now we will also get the partial derivative of u with respect to y. So this time we will find the partial derivative of u with respect to y. This time we will treat the x as a constant and y as an independent variable. Now, what is the derivative of x cubed? The derivative of x cubed is 0 because x is our constant. So the derivative of x cubed would be a 0 plus 3x squared y. As you can see, our constant here are the x squared. So the derivative of this is 3x squared. 3x squared minus the derivative of y cubed. So as you can see, the y is the independent variable. So we can derive this as 3y squared. So the final answer of this partial derivative of u with respect to y would be 3x squared minus 3y squared. So this is our final answer. Problem number 2. F of x comma y is equals to 7x squared minus x cubed y4 plus 5x4 y cubed. So we can use the f sub x and f sub y. f of f sub x and f sub y are same as the formula that we used in problem number 1. So we will first differentiate the f sub x. So what is the different derivative of 7x squared? So we'll write the 7. 7 is a constant, so we will just write the 7. And the derivative of x squared would be the 2x minus the derivative of this. So it would be 3x squared multiplied by the y4, which is the constant. We'll just copy that y4 plus the derivative of 5x4 y cubed. So we'll just copy the 5 because it's constant and differentiate the x4. The derivative of x4 would be 4x cubed. And copy the y cubed to that. Would multiply 7 times 2 would be 14x minus, copy this, 3x squared y4 plus 5 times 4 would be 20x, copy the power cube and copy the constant, which is the y cube. So our final answer is this. Now let's find the f sub y. So we will make the x would be the constant and the y will be the independent variable. So the derivative of 7x squared, as I've said that x is a constant, also 7 is the constant, it would become a 0 minus the derivative of x cubed y4 would be the x cubed multiplied by the y4. This is the independent variable, so we can derive this as a 4y cubed plus the derivative of 5x for y cubed. This would be our constant. It would be, we just copy that 5x 4 multiplied by the derivative of y cubed, which is 3y squared. Now, we will multiply this. 4 times negative x cubed would be negative 4x cubed y cubed plus multiply this 5 times 3, it would be 15x 4y squared. So this is our final answer. Problem number 3. Find the partial derivatives of h, y, z equals to ln square root of x squared plus y squared plus z squared with respect to the independent variable z. First, we will differentiate the ln square root of x squared plus y squared plus z squared. It would become to this. H is equals to ln x squared plus y squared plus z squared 1/2. H equals to, we can transfer this to the front, it would be 1 over 2 ln x squared plus y squared plus z squared. Now, we can derive it using this formula. The derivative of ln u equals to du over u. Now, we will find the partial derivative of h with respect to z. We'll copy the 1/2 times the derivative of our u, which would be the z squared, because the x and the y are constant and z is our independent variable. So the derivative of z squared would be 2z over u, which is this is our u, would be x squared plus y squared plus z squared. 0. After that, we will cancel the 2. Then we will find the partial derivative of h with respect to z is equals to 1 times z is equals to z over x squared plus y squared plus z squared. So this is our final answer. Problem number 4. If f of x comma y comma z is equals to e raised to xy sine xz, find the partial derivative of x, partial derivative of y, and partial derivative of z. So this time, as you can see, we have a function of 3 variables, which is the x, the comma y, comma z. And we are finding the partial derivative of x, y, and z. So it's still the same concept even if you have 3 variables. This time, if we will find first the partial derivative of x, we will treat the y, z as a constant. So we have an e raised to xy sine xz. We will use the product rule because it is a product of two functions. So let's copy first the e raised to xy, then differentiate the sine x. As you can see, the angle of sine is xz, which is the differentiating with respect to x. So the z is the constant. So therefore, when we differentiate it, the sine x would be cos xz. So it would be like this: cos xz. times the derivative of angle of xz, chain rule, which is like a derivative of xz. So the derivative of xz would be z, because we are expecting 2x, plus we will copy the sine xz times the derivative of e raised to xy, So it means we should treat y as a constant. So if we differentiate e raised to xy, we'll just copy it, the derivative of exponent of xy, so we use the chain rule. It is the derivative of xy, so since y is a constant, we will put it aside times to the derivative of 1, so it's just like 1. So put the x, the y. So we'll just simplify it further. So partial derivative of f with respect to x equals to z raised to exy cos xz plus y exy sine z. So this is our partial derivative of f with respect to x. Next, the partial derivative of f with respect to y. So as you can see, the sine xz has no y, variable of y. So it's just like a constant. So we will put it first, the sine xz, because the x is considered as a constant, because we are respecting to y. So the e raised to xy, we are going to differentiate, which is the x are still a constant. So just like what we did on the x, we'll just copy the e raised to xy, then multiply it on the exponent of xy, but this time our x is a constant. So let's copy the x times the derivative of the y, which is also a 1. So it's just like, because we are respecting to y. So the e raised to xy, we are going to differentiate, which is the x are still a constant. So just like what we did on the x, we'll just copy the e raised to xy, then multiply it on the exponent of xy, but this time our x is a constant. So let's copy the x times the derivative of the y, which is also a 1. So it's just like, because we are respecting to y. So only the e raised to xy that we're going to differentiate, which is the x are still a constant. So just like what we did on the x, we'll just copy the e raised to xy, then multiply to our x is constant. X, that, then partial derivative of f with respect to y is equals to, so let's copy the x times the derivative of y, which is, so let's just copy the x times the derivative of y, which is 1. So it's like an x. So therefore we have an x e raised to xy, then sine xz. So therefore this is our partial derivative of f with respect to y.